I'm going to go through these trends pretty quickly because mostly you can just read about it. The alkali metals, group 1A, we see that, and these are just the same trends we've seen that we've been looking at. Atomic radius, density, and reactivity increase as we go down the column. The ionization energy, the electron affinity, and the melting point decrease. Alkali metals have very low ionization energies. They're very willing to lose an electron. That makes them good reducing agents because they're easy to oxidize. They're very reactive, so we don't find them as elements in nature. And the compounds that they make are almost always soluble in water. The alkali metals undergo some reactions that are typical. They will react with nonmetals such as the halogens. And we can predict the formula here because we know that the alkali metals make a +1 ion and the halogens make a -1. They react explosively with water. Here we have a piece of lithium, a piece of sodium, and a piece of potassium. So potassium is very, very reactive. The reason it's very explosive is because hydrogen gas is generated along with a lot of energy. And so you get a lot of heat, and then the hydrogen gas will spontaneously ignite. A little too exciting for my taste. Trends in the halogens, as we're going down, same as the others, increasing atomic radius, density, and melting point. Ionization energy decreases, reactivity decreases. These have very high electron affinities because they prefer to gain an electron. They're good oxidizing agents because they're easy to reduce. These are also very reactive and generally not found uncombined in nature, and their compounds are also very soluble in water. They form halides, metal halides with the metals, not just with the alkali metals, but with pretty much any metal. And so they're going to do that. They will react with hydrogen to form hydrogen halides. When dissolved in water, those hydrogen halides are acidic. Writing reactions like this is good practice, but I wouldn't give you questions exactly like this on an exam because I think it's a little too much. Write a balanced chemical equation for each reaction. The reaction between aluminum metal and chlorine gas. This one should be relatively easy, just using what we've learned about the various elements. So aluminum and chlorine gas. Chlorine is a diatomic element. So a metal and a nonmetal, is this going to be a molecular compound or ionic? It's going to be ionic. So then we're going to predict the formula based on the charges of the ions. What charge does an aluminum ion have? +3. It's in group 3. How about chlorine? Chloride is -1. So based on those charges, we can predict the formula of aluminum chloride, AlCl3. And then we would need to balance this. We look at aluminum, 1 and 1. That's great. Here I've got 3, and there I've got 2. So if I double this, I can make that an even number. Now I've got 6 chlorines. I could put a 3 here to get 6 chlorines, and I need a 2 there. Questions? Reaction between lithium metal and liquid water. Well, lithium metal is Li, solid. Liquid water, H2O, liquid. Predicting these products, I would expect to be challenging for Chem 1A students. So lithium's an alkali metal. Alkali metals react explosively with water because they generate hydrogen gas. So let's think about that. We're going to get hydrogen gas, H2. And then lithium is going to form some sort of a compound with hydrogen and or oxygen, or both of them together. Is it going to be molecular or ionic? Ionic, because we have metals and nonmetals. So we're going to have lithium has a +1 ion. And then what two different, there are actually two different anions that you could pull out of here. What would those be? Yeah, OH negative. And that's actually the correct one. But you could also conceivably think, well, it might be O2 minus, oxide, right? Because you could think, well, if the two hydrogens go off by themselves, that leaves the O, and then, I could get lithium oxide. That's actually not what it does. It does lithium hydroxide. But like I said, I wouldn't really expect you to know that. Lithium hydroxide. If this reaction is occurring in water, that's probably going to be aqueous. And so then we need to balance this equation. I have one lithium and one oxygen on each side. I have two hydrogens here, and I have 2 + 1, 3. So if I double this one, now I've got 4 hydrogens, and I could put a 2 over here, and I've got 4 hydrogens. The oxygens took care of themselves, and then I needed 2 in front of lithium. Balancing that is something you should be able to do. Predicting those products, I don't really expect you to remember that. How about the reaction between gaseous hydrogen and liquid bromine? This one's doable. What's the formula for hydrogen? H2. This is where we need to know our diatomic elements. We're told that it's a gas. What's the formula for bromine? Br2. And it says it's a liquid. Now this is going to form a molecular compound, but it's going to look like an acid, and so we can predict the formula of it because we know the ions that it makes when it's dissolved in water. What do you think hydrogen and bromine are going to make? HBr. If this is happening where it's not in water, which, we have no indication that it would be in water, then this would be a gas. And all we need to balance it is a 2 here. Any questions? Noble gases, again, increasing atomic radius. As you go down, increasing boiling point, increasing density. The ionization energy decreases, but it's still very, very high. Noble gases are exceptionally unreactive. They are only found uncombined in nature. For a long time, up until the 1960s, there were no compounds of noble gases that had been identified. They thought, well, they don't react with anything. Now we know that there are some compounds, but they are not common and they're not found in nature. Noble gases are often used as an inner atmosphere. So if you have something that is going to react with oxygen or nitrogen or carbon dioxide in air, you can keep it from reacting by filling the container with a noble gas, getting rid of the air, because nothing's going to react with a noble gas.